Hello. Hey guys, this is the lecture number 4 on limits, and in this particular video we will solve a lot of questions about limit and we will learn some formulas, right? So let's start the video by showing you the first slide, which is actually some formula, right? So here you can see there is two formulas. One formula is limit extending to 0 e to the power x minus 1 upon x is equals to 1. So what is the formula actually? Limit extending to 0 e to the power x minus 1 upon x equals to 0. So what is the main thing actually? Let me write down that particular thing, which is limit extending to 0 e to the power x minus 1 upon x equals to what? 1. So basically what we have to look is, as extending to 0, that particular part which is actually the the power of exponent, which is x, and that denominator part should tending to 0, right? Should tending to 0. Then that particular limit, that particular function will tending to 1 as x tending to 0. So this is a very important formula. You have to know this particular formula in order to solve some problems, right? And there is another formula which is a limit extending to 0 a to the power x minus 1 upon x is equals to log a, right? Where a should be greater than 0. If a is less than 0, then that will not defined, right? So basically you can understand, right? So instead of e we have only a, instead of e we have a, instead of e we have a, right? So that is why it is actually log a. Similarly, if I just taking these two formulas, then I can write down this particular thing, this total particular thing, as log e base e, that is nothing but 1. So that is why I just write down here 1. So these two formulas are actually very similar, and you can understand that this is literally very similar, right? Okay, so let's discuss another formula, which is what is the value of limit extending to 0 e to the power kx minus 1 upon x. So can you tell me what will be the value of this particular function when x tending to 0? So this is nothing but actually k. How is it possible? Let me clear these things. So basically what we have limit extending to 0 e to the power x minus 1, limit extending to 0 e to the power x minus 1, e to the power kx minus 1 upon x, right? So we have to make that total part and this part as same, right? So can you tell me that we can write down this particular thing or not, right? E to the power kx minus 1 upon kx times k, right? We can write down this particular function as e to the power kx minus 1 upon kx times k, right? We are just multiplying by k and dividing by k, so that you can see that kx and kx will be same. So can you tell me that if x is tending to 0, I mean, and the value of x is very closer to 0, then what will be the value of kx? Can you tell me please? If x is tending to 0, what will be the value of kx? Kx is nothing but tending to 0, right? So as x tending to 0, we can write down these things as kx tending to 0, right? These things as kx tending to 0, right? Just wait a second. As kx tending to 0. So as kx tending to 0, this particular k, right? And this is the function. So since k is a constant term, k should be outside of the limit. We can write down these things, and it will be e to the power kx minus 1 upon kx. So you can see that this particular formula and this particular formula is same, because here instead of x we have kx, right? And as kx tending to 0, so that total part is nothing but 1. So that can be written as k times 1, right? The value of this particular thing is actually k. So you have to remember that particular form value as k. There is no need to write down all these things, but we will solve by this particular way. But in order to solve these problems in a competitive exams, you don't need to understand, you don't need to write down all these steps, because that steps will consume a lot of time, right? So you have to learn, you have to keep in your mind that limit extending to 0, e to the power x minus 1 upon x would be 1, and limit extending to 0, a to the power x minus 1 upon x is nothing but log a, and limit extending to 0, e to the power kx minus 1 upon x is nothing but k, right? So you can understand there is actually 3 formulas is there, right? Okay, let's move to some questions. Here you can see that the question is that the first question is limit extending to 0, 5 to the power 2x minus 1 upon x, right? So let me solve this particular question, right? So basically what happened is we can write down this particular function as 5 to the power 2x minus 1 upon, let me multiply this x with 2 and divide by 2, right? Then you can see that after multiplying by 2 and divide by 2, that particular function would form like that, right? That particular function would form like that. And here you can see that this is the function and 2 is multiplied with this function. So since 2 is a constant term, so 2 can be outside of the limit, and it will be 2 times limit extending to 0, 5 to the power 2x minus 1 upon 2x, right? So 2x as same, but here we have x tending to 0, that should be making as 2x tending to 0. So since x tending to 0, can you tell me what will be the value of 2x? 2x will always tending to 0, because x tending to 0 means x is very close to 0. So since x is very close to 0, then what about 2x? 2x is also close to 0. So we can write down this particular thing as 2 times limit 2x tending to 0, 5 to the power 2x minus 1 upon 2x, right? So here you can see that 2x is there, 2x is there, and 2x is there. I mean, these 3 terms are actually same, and that term is actually tending to 0. So this is actually the form of limit extending to 0, a to the power x minus 1 upon x, which is nothing but logarithm of a, I mean that particular thing. So that can be written as 2 times logarithm of 5 with base e, right? So the value of this particular limit is actually 2 times logarithm of 5 by e, right? This can be also written as here you can see that, let me clear these things so that after that I will discuss it. Let me write down all these things at there. So basically what we have, actually we have limit extending to 0, 5 to the power 2x minus 1 upon x, right? So limit extending to 0 is there, right? 5 to the power 2x can be written as 5 square to the power x, I mean 25 to the power x, right? Minus 1 upon x. So here you can see that that is actually formed the same, right? Form the same like limit extending to 0, a to the power x minus 1 upon x, right? So that is nothing but equals to log 25, right? So 25 base e. So 25 can be written as 5 square, and you know, right, log a to the power n can be written as n log a. So 5 to the power 2 can be written as 2 log 5, right? Base e. So that is also same, right? Yeah, you can understand what am I actually trying to say, right? Yeah. So let me clear that particular thing. Just write down these things so that we will clear the total part and solve this second one. Okay, let's clear that part. Let's clear that part. Just wait a second. Hold on a minute. Hold on a second. Yeah. So wait a second. Yes. So can you tell me how can I find out the value of this particular function? It is very simple, right? It is very simple. So first of all, here you can see that x tending to 2, but we have to make some functions which is actually tending towards 0 so that we can make the formula. So first of all, your main motto should be putting the value in the function and check whether that value will be exist or not. I mean the value of this particular function will undefined or not. When you put x x equals to 2 on that function, so that total part will tending to 1, right? And that is 1, so 1 minus 1 is nothing but 0, so the numerator is actually 0. And what about denominator? When you put x equals to 2 on the denominator, it will give you 2 minus 2, which is nothing but 0. So it is actually 0 by 0 form, I mean undefined form, right? Undefined form. So we can't solve this particular limit by putting the value, I mean the substituting the value of x as 2, right? So here you can see basically we have x minus 2 terms, x minus 2, right? So I have to make that term as x minus 2 so that it will be looking like as the formula, right? So since x is tending to 2, so can you tell me what will be the value of x minus 2? I have already discussed with you that x minus 2 will tending to 0, because we have to think this particular thing as x equals to 2, right? So if x equals to 2, then what will be the value of x minus 2? X minus 2 is nothing but 0. So let's remove that equals to as tending to, right? So if we just remove that equals to as tending to, then x minus 2 is nothing but tending towards 0, right? So that particular limit can be written as limit x minus 2 tending to 0, we have 5 to the power 3 times x minus 2 minus 1 upon x minus 2, right? So now we have to make that particular function as a to the power x minus 1 upon x, right? So let's make this particular function. So basically we have limit x minus 2 tending to 0, that will be 5 to the power 3 times x minus 2 minus 1 upon, we can multiply this x minus 2 with 3, right? And we have to multiply this total function with 3, right? After that we can, after cancelling this 3, it will be same as the previous one, right? It will be same as the previous one. But here you can see 3 times x minus 2 is there, 3 times x minus 2 is there, but here only x minus 2 is there. So let me just take that 3 outside of the limit. So it will be 3 times limit x minus 2 tending to 0, we have 5 to the power 3 times x minus 2 minus 1, and the denominator will be 3 times x minus 2, right? 3 times x minus 2. So as x minus 2 is tending to 0, so can you tell me what will be the value of 3 times x minus 2? It is always tending to 0, because x minus 2 is almost equals to 0. So what will be the 3 times x minus 2? It is nothing but 0, right? So we can write down that limit as limit 3 times x minus 2 which tending to 0, and we have 5 to the power 3 times x minus 2 minus 1 upon 3 times x minus 2, right? So what we have actually, you can see that this particular function would make the formula, right? Limit x tending to 0, a to the power x minus 1 upon x is nothing but log a, right? With base e, right? So that can be written as log 5 with base e, right? So it is actually 3 times log 5 base e. So the value of this particular limit is actually 3 times log 5 base e. So this is also a very nice question, right? So let's move to the next question. I will give you a little bit time so that you can think about these questions. So please think about that question. Yeah, I think you have think about this question. So basically it is not actually as the formula, right? It's not looking like the formula. So first of all, let me put the value. When you put x is equals to infinity, then that part will become infinity, because here we have x only, and on the right side in that part we have 5 to the power 1 upon infinity, which is nothing but 5 to the power 0, because 1 by infinity is nothing but 0. So 5 to the power 0 is nothing but 1. So 1 minus 1 is actually 0. So that part will become 0 and that part will become infinity. So it is of the form infinite times 0. So it is actually an undeterminate form, because infinite times 0 have no value in real line, right, or any complex line. So this is actually in undeterminate form, right? This is actually undeterminate form, right? So how we can solve this question? Basically we have to try to make that function tending to 0, right? So in order to make that particular function and that particular variable which is x tending to 0, let x equals to 1 upon t, right? I have already discussed with you that when x tending to infinity is there and there are some function, so basically if there doesn't exist any kind of formula, then you have to take x equals to either 1 upon t, x equals to minus t. It will be vary depending on the question, right? So as x tending to infinity, what about t? T is actually tending to 0, right? So we can write down that particular limit as limit t tending to 0, and that particular function will become as x can be written as 1 upon t, because we took that thing x as 1 upon t, and that particular part will become 5 to the power t, because 1 upon x is nothing but t. Since x equals to 1 upon t, what will be the value of t? T is nothing but 1 upon x, right? So it will become 5 to the power t minus 1, right? So that can be written as limit t tending to 0, 5 to the power t minus 1 upon t, right? So that can be written as, here you can see that t tending to 0, 5 to the power t minus 1 upon t. So the value of this particular limit is log 5 with base e, right? So you can understand how we can solve this question, right? This is very easy question. You have to just put x equals to 1 upon t in the question so that you can get the solution. It is very easy question, right? Okay, so let's move to another question. It is a very important and interesting question also. This is very important for IIT JEE mains and some other state level engineering entrance exams also, right? So can you tell me how can I solve these questions? First of all, you have to check in your mind that whether the substitution method would work or not. So basically when you put x as 0 on the numerator, then it will become 5 to the power 0 minus 7 to the power 0. So 5 to the power 0 is nothing but 1, and 7 to the power 0 is nothing but 1, right? So the numerator will become 1 minus 1, right? So 1 minus 1 is nothing but 0. Similarly, if we put x as 0 on the denominator, then that particular part which is 3 to the power x will be 1, because it will become 3 to the power 0, and 3 to the power 0 is nothing but 1, and that particular part which is 2 to the power 3x will become 2 to the power 0, because as x tending to 0, 3x will tend to 0, so that will become 2 to the power 0. So 2 to the power 0 is nothing but 1, right? So 1 minus 1 is also 0, so the denominator is also 0. So actually this function would become 0 upon 0 form, right? So 0 upon 0 is nothing but undeterminate form, right? Undeterminate form. So we can't solve by substitution method, right? So we can't solve this question by substitution method. So we have to think about any other formula. So basically can you tell me like how we can solve this question? So let me write down for you one step, which is limit x tending to 0, 5 to the power 2x minus 1 minus 7 to the power 2x minus 1. Can I write down this particular numerator as 5 to the power 2x minus 1 minus 7 to the power 2x minus 1? Because when we expanding that particular thing, then 1 and minus 1 will be cancelled out, right? Similarly, we can write down the denominator as 3 to the power x minus 1 minus 2 to the power 3x minus 1, right? So we are just moving on step further. So basically we have to divide the numerator and the denominator by x, right? We have to divide the numerator and the denominator by x, so that will make the easiest form as the formula, right? So let me divide that particular denominator with x also. So it will become 2 to the power 3x minus 1 upon x, right? So let me change the limit, right? Since limit fx upon gx can be written as limit fx upon limit gx, so that will become limit x tending to 0. Let me use the white color. So that will become 5 to the power 2x minus 1 upon x minus 7 to the power 2x minus 1 upon x, right? And the denominator will become limit x tending to 0, that will become 3 to the power x minus 1 upon x minus 2 to the power 3x minus 1 upon x, right? So I have already solved that what will be the value of this particular thing, what will be the value of this particular thing, what will be the value of this particular thing, and what will be the value of this particular thing. Basically there are some constant different constants are there, but the formula and the way of solution is same. So 5 to the power 2x minus 1 upon x can be written as 2 log 5, right? 5 base e. Similarly 7 to the power 2x minus 1 upon x, when limit extending to 0, that will form as 2 log 7 base e. Similarly, the denominator will become log 3 base e minus that particular part will become 3 log 2 base e, right? So here you can see that particular numerator will become numerator can be written as log 5 square because 2 is there, so 2 can be write down as 5 square, so that will become log 25 up base e minus that can be written as log 49 base e, and the denominator can be written as log 3 base e minus that can be written as log 2 cube, which is 8 base e, right? So you have to just use the another formula, which is log c minus log d. Log c minus log d can be written as log c by d when c and d are positive terms, right? So that log 25 minus log 49 can be written as log 25 upon 49. Similarly, the denominator can be written as log 3 upon 8 base e, right? So that particular part, since log a by log b is there, so we can subtract them, right? We can subtract them, so that will become log 25 by 49 minus 3 upon 8. You can solve this question, you can solve this particular thing, which you can easily do it. So that is the actual answer. You can let this particular thing as it is, there will be no issues. So the answer of this particular given equation is actually this, and this is also, because they are both same. I'm just using some properties of logarithm, right? So you can understand how we can solve this question, right? So let's move to another question. This is also you can think about it, right? So first of all, let me check. When we put x is equals to 0 on the numerator, first of all I have to check about the substitution method, right? So when we put x equals to 0 on the numerator, then the numerator will become e to the power 0, which is nothing but 1. So 1 minus 1 will become 0, right? So the numerator will become 0. And what about denominator? Denominator will also become 0. So that is actually 0 by 0 form, I mean undeterminate form. So that is very difficult to solve. I have to use the formula, right? So what we can write down is limit x tending to 0, that particular thing can be written as e to the power x cube minus 1 upon x cube times x, right? That particular thing can be written as this, right? So basically you can see there is two functions. One function is this and another function is this. So one function is actually e to the power x cube minus 1 upon x cube, and another function is x only, right? So we can use the properties of limit, which is actually limit fx into gx can be written as limit of fx into limit of gx, right? So that can be written as limit x tending to 0 e to the power x cube minus 1 upon x cube times limit x tending to 0 x, right? So basically, since x is tending to 0, can you tell me what will be the value of x cube? Since x is tending to 0, I mean x is very closer to 0, then x cube will always closer to 0, because if x equals to 0, then what will be the value of x cube? It is nothing but 0. So we can write down this x is tending to 0 as x cube tending to 0, and that particular function can be written as e to the power x cube minus 1 upon x cube, and that particular part can be written as limit x tending to 0 x, right? So here you can see that part is actually 1, because this is of the form, right? Limit x tending to 0, I mean limit t tending to 0 e to the power t minus 1 upon t, right? So the value of this particular thing is actually 1, and that particular value, can you tell me what will be the value of that particular thing? It is actually 0, because when x tending to 0, x will become 0, right? So 0 is a finite number and 0 is a real number, so I have to take 0. So 1 times 0 will become 0, right? So there is no issue, so you can understand. So the value of this particular function, is actually 0, right? Right. Okay, so let's move to another question. This is a question of JEE Mains. I think this questions asked in 2020. Maybe I didn't recall the exact date. I mean exact year, but it was around 2020. Yeah. So can you tell me how can I solve this question? I will give you around 1 minute to think about this question, so that when I will give you the solution, you will realize that this question is literally very nice, and the solutions are literally very attractive and very interesting. So please think about this question, then we will give you the solution, about the detailed solution. Have you done? I believe that you are trying, right? So please try to do this question. After that I will give you the solution, right? I will wait for a few seconds, then I will start to write down the solution. So first of all, here you can see that we can't actually using the formula of a to the power x minus 1 by x or something like that, because this is little bit complex function is given to you. So first of all, you have to make that particular function in the right way, right? So that you can think about this particular function. So basically here limit of x tending to 2 is given to you, and you can write down the numerator as 3 to the power x, plus that particular part can be written as 3 to the power x upon 3 minus 12 upon, that can be written as 3 to the power minus x, right? Minus 3 to the power minus x minus 3 upon 3 to the power x, right? That can be written as like that. So limit x tending to 2 is there, right? Limit x tending to 2 is there. So what about the numerator? Can you tell me? Suppose if I will take common 3 to the power x from these two part, then that will become 3 to the power x times 1 plus 1 upon 3, right? Minus 12. And if I will taking the LCM as 3 to the power x on the denominator, then that will become 3 to the power can you tell me what that particular, here you can see that it is actually x upon 2, so that will become actually 3 to the power x upon 2, right, minus 3, right. So I think there is some glitch happened in my desktop, but I will resolve it after solving this question, right. So here the numerator will become 4 upon 3 times 3 to the power x minus 12, and the denominator can be written as 3 to the power x upon 2 minus 3, right, times 3 to the power x. That particular 3 to the power x is written like that because when we put x as 2, then that particular part will not give me any kind of problem. I mean 3 to the power 2 is nothing but 6, which is a real number, so a real number will not give me any kind of trouble, right. So that can be written as limit x tending to 2, that part will become 4 times 3 to the power, here you can see 3 to the power x is there and 3 is on the denominator, so that can be written as 3 to the power x minus 1 minus 12, and the denominator can be written as if I will take common, which is actually 3, right. Can you tell me how can I write down this thing, like can you please tell me, like if I will take 3 common, then what will be the value? It is actually 3 to the power x by 2 minus 1, right, 3 to the power x by 2 minus 1, and that will be minus 1, right. And I have to split the limit into 2 factor, which is limit x tending to 2, 3 to the power x. So I can take 4 common from these 2 part, right. So if I will take 4 common and I have to take 3 common, then that will become 4 upon 3, and on the right side we will have x to the power x tends to 2, 3 to the power x minus 1 minus 4, I think 3, it's 3, wait a second, it's 3, and the denominator will become 3 to the power x minus 2 upon 2, right, minus 1. And that particular value, can you tell me what will be the value of this? Because if we put x as 2 on that particular 3 to the power x, it will not make me any trouble, so that will become 3 to the power 2, right. So now you can see that 4 by 3 is there, 3 to the power 2 is nothing but 9, that will be outside of the limit, right. And here you can see we can take 3 common from these 2 function, right. So if I will take common 3, then we will have limit x tending to 2, 3 to the power x minus 2 minus 1 upon 3 to the power x minus 2 by 2 minus 1, right. So here you can see 3 will be cancelled out, 4 times 9 will be 36, right. 36 times limit x tending to 2, we will have 3 to the power x minus 2 minus 1, and that will have 3 to the power x minus 2 upon 2 minus 1, right. So the next step will be, since x tends to 2, we can write down x minus 2 as tends to 0, right. So that will be 36 times limit x minus 2 tends to 0. So the numerator should be divided by x minus 2, so that will make the form, and the denominator should be divided by x minus 2, right, x minus 2. So after solving this total part, the numerator will give me log 3, because you can check it by yourself, because this is very easy. And if I solve the denominator by multiplying 2 and dividing 2, right, because then that will make the form, just wait a second, hold on a minute, just hold on a second, yeah. So that will be divided by 2 and multiplying by 2, so it will give me half times log 3, right. So log 3 will be cancelled out, and 36 times 1 upon 2 can be written as 2. So the value of this particular thing is 36 upon minus into 2, which is nothing but 72. So what will be the value of this particular limit, which is actually 72. So here you can see the solution of that particular particular equation, right, particular question. So you can check it. Then we will move to the next slide, right? So basically what we did is we can write down 3 to the power x minus 1 as 3 to the power x upon 3, and on the denominator we also can write down 3 to the power 1 minus x as 3 upon 3 to the power x. Then we took LCM on the denominator. After that we will take some common, we will using some properties of limit. After that we are just trying to make as the formula, and then we can solve this particular limit as this particular thing, right? It makes hazy, but you can understand what I did actually, right? After that we will get the value of this particular limit as 72, right? Okay, so let's move to the next slide. Yeah, so here is actually two formulas is given to you. The first formula is limit x tending to 0 log 1 plus x with base e upon x is equals to 1, right? So here you can see x is there, and x is there, and that particular x is actually tending towards 0, right? So let me again say that limit x tending to 0 log 1 plus x with base e upon x is equals to 1. So that is actually the formula, right? One of the formula of limit. So can you tell me what will be the value of this particular limit? So here you can see we have kx, right? It is not equals to x, right? Since kx is there, then we can write down the limit, the function as log 1 plus kx upon kx times k, right? I'm just making like this particular formula. So since k is constant, then k will be outside of the limit, and here we have kx, but here we have only x, but x is tending towards 0. So can you tell me what will be the value of kx? Since x is tending towards 0, then the value of kx is nothing but tending towards 0, right? Because if x is equals to 0, then kx equals to 0, right? So that particular thing will become limit kx tending to 0, and the function will be log 1 plus kx upon kx, right? So here you can see kx. If we put kx equals to t, then that will become limit t tending to 0 log 1 plus t upon t. So that is equals to that particular formula. But we don't need to let that particular kx equals to t, because we can understand now that kx is tending towards 0, and we have log 1 plus kx upon kx. So that is nothing but, that total part is nothing but 1 as the given formula, right? So it will become k times 1, which is nothing but k, right? So that particular limit, the value of this particular limit is actually k, right? We will solve some problem, but you don't need to write all these steps, because in order to solve the problem in competitive exams, you have to first you have to think about the formula, right? You don't need to think about the detailed solution, right? Okay, so let's move to some formula. Before that, just let me again say that limit x tending to 0 log 1 plus x base e upon x is equals to 1, and the second part is limit x tending to 0 log 1 plus kx base e by x is nothing but k, right? Yeah. Okay, let's move to the next slide. So I think this is a very important question, and also you may feel like it is a kind of difficult question, but it is not. So can you please try to solve this question, which is actually limit x tending to 2 ln is nothing but just let me write down this thing as just wait, hold on a second. Let me just write down this thing as log base e, right? So don't log base e is nothing but ln, right? You know, if log base e x is there, that can be written as ln x, right? So we have limit extending to 2 log x minus 1 with base e upon x minus 2. So can you tell me what will be the value, what will be the value of the limit? Just think about this question. After that I will give you the solution, right? Here basically we have to make the particular function as the previous formula, right? What we have already did in a lots of questions, right? So you can think it, right? That can be written as limit extending to 2, and now the numerator can be written as log base e into log 1 plus x minus 2, right? Here you can see that particular x minus 1 can be written as 1 plus x minus 2. So after looking into that particular thing, which is 1 plus x minus 2, that is nothing but x minus 1, right? So this is actually equals to x minus 1, right? And the denominator is actually x minus 2. So here you can see that x minus 2 is there, x minus 2 is there. And since x tending to 2, then what will be the value of x minus 2? Where the x minus 2 will tends to. It will be actually x minus 2 will tends to 0, right? Since x tending to 2, then x minus 2 is actually tending to 0. And we have log 1 plus x minus 2 upon x minus 2. So what will be the value of this particular limit? First of all, you know, right, limit x tending to 0 log 1 plus x upon x is nothing but 1. So here instead of x we have x minus 2. If we put x minus 2 as t, then that particular function will changing to limit t tends to 0 log 1 plus t upon t, which is equals to 1. So this total part in without letting that particular x minus 2 as t, we can say that this limiting value is nothing but 1, right? So the value of this particular limit is equals to 1, right? So similarly, can you tell me what will be the value of this? Since we have done a formula of limit x tends to 0 logarithm of 1 plus kx with base e upon x is equals to k, and here ln is nothing but log base e, right? Ln is nothing but log base e. So you don't need to worry about the ln. So that is actually equals to 3, because we have to write down the k only, right? What we have did, right? Here you can see that 1 plus kx upon k is nothing but x is nothing but equals to k, right? Equals to k. Here you can see, right? So the value of this particular limit is nothing but 3, right? So let's move to another question. This is also a very nice question. The question says limit extending to 0 log 1 plus 2x base e upon 3 to the power x minus 1. So can you tell me what will be the value of this particular limit? Just try to do it by yourself. After that I will give you the solution, right? Just try to do it by yourself. Yeah, you are right that we can divide this numerator and denominator by x, right? Because it is not included only one formula. You can see that after substituting the value of x as 0, it will become log 1 plus 0, log 1, and you know log 1 base e is nothing but 0, right? And the numerator will also become 0, because 3 to the power 0 is 1 and 1 minus 1 is 0. So that numerator is 0 and the denominator is 0. So that particular function is forming as as 0 upon 0. So how we can solve this? We have to divide, divide the function by x, right? We have to divide the function by x. So let me divide that function by x. Then what this particular numerator will become? It will become log e 1 plus 2x upon x, and the denominator will become 3 to the power x minus 1 upon x, right? So since function, this is the function, this is another function, and these functions are actually one upon another, I mean fx upon gx. So we can change the limit into two parts, right? So one part is actually limit x tending to 0, we will have log 1 plus 2x upon x, right? And on the denominator we can write down this as limit x tending to 0, 3 to the power x minus 1 upon x, right? 3 to the power x minus 1 upon x. So what will be the value of this numerator? Since we have log 1 plus 2x upon x, so the value of this particular thing is actually 2, right? And the denominator will become log 3, I mean base e, right? So the value of this particular given limit is actually 2 upon log e base 3, right? That can be also written as 2 log base 3 e, I mean e base 3, right? So this is similar as this, right? So this is the solution, I mean this is the value of this particular limit, right? Okay, so let's move to another question. This is also very important question and very interesting questions also. So can you please solve this question by your own? After that I will give you the detailed solution of that question, right? So please do this question by yourself. I'll give you some seconds or something. So okay, I will give you the solution. So first of all, here you can see that on the numerator we have log a minus log b type of form. So we know, right, log a minus log b can be written as log a by b, right? So we can write down that particular thing as limit x tending to 0. The numerator can be written as log, right, 5 plus x upon 5 minus x, right? And the denominator will be x only. So what we have to make, basically when we substitute the value of x, then you can see that that particular thing will become 0 upon 0, I mean undeterminate form. So you can't solve this particular limit in this particular question by substituting the value of x, right? So that will become limit x tending to 0. We have to make that particular logarithm of any function as log 1 plus something, right? So let me write down this by log 1 plus 5 plus x upon 5 minus x minus 1, right? I can write down that 5 plus x upon 5 minus x as 1 plus 5 plus x minus by upon 5 minus x minus 1, because minus 1 and plus 1 will be cancelled out, and the denominator will be as it is, right? So that will become limit x tending to 0 log 1 plus, here we can write down this 5 plus x upon 5 minus x minus 1 as, when you take 5 minus x as LCM, so we will have 5 plus x minus 5 plus x, right? And on the denominator we have only x. Similarly, that can be written as limit x tending to 0, we have logarithm of 1 plus, here 5 and minus 5 will be cancelled out, right? So we have 1 plus 2x upon 5 minus x upon x, right? So basically it makes like 1 plus something upon that particular something should be there. So here we can write down limit x tending to 0, limit x tending to 0 log 1 plus 2x upon 5 minus x. Let me write down by 2x upon 5 minus x and multiply it by what, can you tell me? By 2x upon 5 minus x, and 1 upon x is there, so we have to multiply it by 1 upon x, right? So I think after cancelling this total part, we will have that particular part again, right? So here you can see x and x will be cancelled out. What we will have limit x tending to 0 logarithm of 1 plus 2x upon 5 minus x, and on the denominator we have 2x upon 5 minus x, right? And on the right hand side we can write down this part as limit x tending to 0 2 upon 5 minus x, right? So that part can be easily solvable by substituting method. When you substitute x by 0, then that will become 2 by 5, right? So there will be no issue. So can you tell me, like we have to make the form as log 1 plus x upon x, and that should be there, right? So as x tending to 0, can you tell me what will be the value of 2x upon 5 minus x? That is always tending to 0, because when you put x equals to 0, then 2x upon 5 minus x will be 0, because here x will be 0, and that the denominator part, which is 5 minus x, will be only 5, right? So as x tending to 0, we can write down that part as limit 2x upon 5 minus x tending to 0, right? So we will have log 1 plus 2x upon 5 minus x, and on the denominator we have 2x upon 5 minus x, and on the right side we have limit x tending to 0 2 upon 5 minus x, which is nothing but 2 by 5 minus 0, right? So here you can see 2x upon 5 by 5 minus x is there, 2x upon 5 minus x is there, 2x upon 5 minus x is there. So these are similar, and that particular part is actually tending towards 0. So that total part will be equals to 1, and that particular part will be 2 upon 5, right? So this is nothing but equals to 2 upon 5. So what will be the value of this particular limit, which is nothing but 2 upon 5. I think you understood, right, what I actually did in this particular question, right? I'm just basically first use the logarithm property. After that I'm just trying to make this particular thing as 1 plus something. So in order to making 5 plus x upon 5 minus x as 1 plus something, I have to write down this thing as 1 plus 5 plus x upon 5 minus x minus 1. Then I'm just trying to solve the 5 plus x upon 5 minus x minus 1, and after that applying some methods and applying some process, and after that we can find out the value of this particular thing is equals to 2 upon 5, right? Value of this particular things is equal to 2 upon 5. So what is the value of this limit? It's actually 2 upon 5, right? So I believe that you can understand, you understood, right? Okay, let's move to a particular formula, which is actually limit x tends to 0 a to the power x minus b to the power x upon x, which is equals to log a upon b, where ab should be greater than 0. So how this formula comes? Let me write down this thing, which is limit x tending to 0 a to the power x minus b to the power x upon x. So this a to the power x minus b to the power x can be written as limit x tends to 0 a to the power x minus 1 minus b to the power x minus 1 upon x, right? And that can be separable, we can separate these parts, right? So that will be limit x tending to 0 a to the power x minus 1 upon x, and that will be b to the power x minus 1 upon x, right? And since limit fx minus gx can be written as limit fx minus limit gx, right? And x tends to 0 will be always there. right? So limit x tending to 0, a to the power x minus 1 upon x minus limit x tending to 0, b to the power x minus 1 upon x, right? So that particular part can be written as log of a, right? So that particular part can be written as log of a with base e, right? And that particular part can be written as log of b base e, right? So log of a minus log of b can be written as log a by b, since a, b are positive number, right? Log a by b is base e because a, b should be positive, because otherwise that logarithm function will not defined, right? So here you can see how the proof came, right? So this is actually the formula you have to remember, right? So that you can solve some questions related to this topic very easily, right? So this is another formula, which is limit x tending to 0, 1 plus x to the power n minus 1 upon n. I mean, if there will be any function like 1 plus x to the power n minus 1 upon x and x tending to 0, then that particular thing is equals to n. Suppose if I will give you limit x tending to 0, 1 plus x to the power 5 minus 1 upon x, then that particular thing has the value only 5, right? So you can understand, right? Yeah. So there are a lot of things about trigonometric limits and all these things, which I will discuss in the later video. Till then, I'm just giving you an example about this particular topic, which is suppose limit x tending to 0, 1 plus 5 upon 2x to the power 5 minus 1 upon x. Can you tell me what will be the value of this particular thing? Most of the guys will tell me, sir, the value of this particular function with limit x tending to 0 is nothing but 5 by 5 only. But that's not the correct, because we have to make that particular function as 1 plus x to the power n minus 1 upon x, right? Since 5 by 2 times x is there, so can you tell me when x tending to 0, we can write down 5 by 2 times x tending to 0, because as x equals to 0, 5 by 2 times x is also equals to 0. So 5 by 2 times x will tending to 0. So on the numerator we will have 1 plus 5 by 2 times x to the power 5 minus 1 upon, we have to write down that x as 5 by 2 times x, and we have to multiply this total function by 5 by 2. So after cancelling this 5 by 2 and 5 by 2, that total function will be as it is, as the previous one, right? So here you can see that 5 by 2 should be outside of the limit, right? So 5 by 2 should be outside of the limit, and what we will have, we will have limit 5 by 2 x tending to 0. You have to write down here that as x tending to 0, 5 by 2 times x should be tending to 0, So the numerator will become 1 plus 5 by 2 times x to the power 5 minus 1 upon 5 by 2 times x, right? So here you can see that part and that part and that part has equal, right? They all are equal, and that particular part is actually tending towards 0. So you can see that this particular form and this particular form are actually same. If we put 5 by 2 times x equals to t, then actually these are same. You have to think in a wide variety. You have to think a lot of wide perspective. So you can realize that limit 5 by 2 times x tending to 0, 1 plus 5 by 2 times x to the power 5 minus 1, I mean 1 plus 5 by 2 x whole to the power 5 minus 1 upon 5 by 2 times x is nothing but 1, right? I mean that particular part is equals to 1, right? So it will be 5 by 2, sorry, that particular value will be only 5, because 1 plus x to the power n minus 1 upon x is nothing but equals to n, right? So that will be 5 by 2, which is actually there, and that total part will be 5. So 5 times 5 will be nothing but 25 upon 2. So the value of this particular limit is actually 25 upon 2, right? So you can understand, you understood about about that particular example, right? How we can solve this question. So in the upcoming videos or in the upcoming streaming videos, we will learn about trigonometric limits, and after that we will solve lots of questions related to trigonometric limits, and after that we will discuss some theories and some examples and some problems, and then we will go to the previous year question papers about on JEE Mains, JEE Advanced, some other state level engineering exams like that. So till then, stay tuned with us and follow us, and we'll meet again, right? Thank you for attending this lecture. Thank you so much.